Yes, good evening, everyone. Yes, good evening, everyone. Am I audible? Please let me know in the chat box whether am I audible. Hello, am I audible? Please let me know in the chat box. Anyone, please confirm me. Yeah, thank you. So let us start this session. And before going to start this session, can I know how many of you know KMAP related theory already, so that we can start with problem discussion? I hope in group also have kept a poll about KMAP related theory. I hope majority has given that they already know about that. Okay, so we are going to start with KMAP problems. Okay, so before that, if I want to give a brief idea about KMAPs, so basically these are used for Boolean algebra solving. And we do have something known as SOPs and POS. SOP basically stands for sum of product, and POS can stands for product of sum. Okay. So any particular expression, if we are going to have, we can represent that particular expression in two formats. One is sum of products, and another is product of sum. Okay. So let me show you what do you mean by sum of product and what do you mean by product of sum. One second, let me open it. And before that, anyone having any queries or any doubts in the previous sessions? In the previous sessions, we have discussed about problems related to logic gates. I hope those are all clear, right? Yeah. So if you're having any doubts or any queries in those particular problems, you can just let me know so that we can have the discussion on that also. So let me share my screen. And before that, my voice is clear, right? Is there any disturbance or is there any disturbance? My voice is clear, right? Okay, great. Thanks for letting me know. So let us start this session. One second, let me share my screen. Okay. So if I'm going to have any particular three variable or two variable function, let's say f of a, b, c. Let's say if I'm going to have a three variable function, which is represented as a complement bc plus abc plus bc complement plus a. Can anyone tell me whether it is represented in SOP format or POS format of representation? This particular function which I have written over here, is it SOP form of representation or POS form of representation? It is a simple question. SOP form of representation. That is nothing but my sum of products. Okay. So basically, this is represented as SOP form of representation, which is nothing but my sum of products. Okay. Now, can anyone let me know the minterms which are present in this particular expression? What are the minterms in this expression? What are the different minterms which are present in this particular expression? Let's see who can answer this. ABC is one minterm. Okay. I got one answer. ABC is one minterm. And what are the other minterms we do have? We can basically derive from this particular expression. ABC. And so minterms are nothing but my product terms. Okay. I got one answer from YouTube chart. It's ABC. Yeah. And what are the other minterms? Only one minterm. So for a three variable function, for a three variable function, I'm going to have total possible minterms are 2 power 3, which is 8 minterms. So out of 8 minterms, do I have only one minterm, which is ABC, and there are no other minterms? Okay, I'm waiting for your answers. Okay, fine. So basically, we cannot directly find out the minterms by seeing this particular expression because it is not in canonical form. This particular expression is not written in canonical form. So that's the reason I cannot take minterms directly. Okay. So what I should do this, I should basically convert this into canonical form. I should convert this particular expression into canonical form. Then after converting into canonical form, I can derive my minterms from this particular expression. Okay. So how to convert this into canonical form, which is nothing but A complement BC plus ABC plus BC complement into A plus A bar plus A into B plus B bar into C plus C bar. Okay. Then I'm going to convert it into canonical form as this. So which is nothing but A complement BC plus ABC plus ABC complement plus A complement BC bar plus AB plus AB complement into C plus C complement, which is nothing but ABC plus ABC bar plus AB bar C plus A B bar C bar. Okay. So from here, I can basically take my midterms. So this is now in SOP form of representation, you are going to represent your complemented variable with 0 and non-complemented variable you are going to represent as 1. Okay. So which is nothing but 0, 1, 1, 1, 1, 1 and 1, 1, 0, 1, 0, sorry, 0, 1, 0 and this is 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0, 0. Okay. So what are the midterms I'm going to have, which is nothing but 3, 7, and 6 is one of the midterm, and 2, and this is 7, 6, 5. So these are the midterms which are present in this particular expression. Okay. So before 2, 3, 4, 5, 6, 7. Exactly. 2, 3, 4, 5, 6, 7. Exactly. So you need to first of all make sure that that particular expression is written in canonical form. Then only you can basically derive the midterms. Okay. So before you cannot directly take the midterms. First of all, you need to perform you need to convert it into canonical form. Then only you can basically derive the midterms. Okay. Yes. Is it clear for everyone? Any doubts or any queries? Yes, exactly. There are only 2, 3, 4, 5, 6, 7. These are the midterms which are present. Okay. Now, similarly, in the case of your POS form of representation, also, if I'm going to have any kind of a function which is basically represented in POS form of representation, let's say f of ABC, which is equal to, let's say, A plus B plus C complement into A plus B plus C. Now, what are the max terms which are present over here? This is a very simple question. What are the max terms which are present in this particular expression? Exactly. 1 and 0. Now, in the case of your max terms, you are going to represent your variable, non-complemented variable with 0 and complemented variable with 1, which is nothing but this is this is basically 0, 0, 1, and this is 0, 0, 0, which is nothing but max terms are pi m 0, comma 1. These are my max terms. Okay. Now, why we need to know this? If we are going to deal with KMAPS, I'm going to have minterms and max terms. If my expression is represented in SOP form, or if my expression is represented in POS form of representation, then obviously I need to know, or obviously I need to have the knowledge of minterms and max terms, right? So without that, we are not going to solve it. Okay. Yes. So before actually going to start discussing about problems related to KMAPS and a few problems. First, let's discuss about implicants in KMAP, right? So let us try to understand something known as implicants in KMAP. So in my KMAP, I'm going to have this few implicants. One is prime implicant, and second one is essential prime implicant, and followed by redundant prime implicant. Okay. And followed by I'm going to have selective prime implicant. So these are the different kind of implicants I'm going to have in my KMAP. Okay. So first one is prime implicant, essential prime implicant, redundant prime implicant, and selective prime implicant. Right. So let us try to understand what do we mean by first of all implicants. Okay. Now, so first of all, let's say if I'm going to have a three variable function f of a comma b comma c, and I'm going to consider the SOP form of representation. So how let's take a simple key map like this. So this is a simple three variable K-map with eight number of cells. So for a three variable function, we are going to have eight number of cells. And let's say this is A and this is B and this is C. Let's say if I'm going to have minterms like this, okay, which is present at the positions 4, 5, 7, 6. So have the minterms at 1, 3, 6, and 7. So these are the minterms which are present. Okay. Now, what we are going to have, these are my minterms, right? Now, what do you mean by prime implicants? So basically, prime implicants are the implicants where those are nothing but all the possible groups in a particular K-map is known as prime implicant. So this is one possible group which is possible, okay, and this is one possible group, and this is also one possible group. So what are the prime implicants over here? So prime implicants are basically equal to 3. Okay. So this is how we are going to find out the prime implicants. Okay. Now, next one is essential prime implicants. Now, what do you mean by essential prime implicants? Essential prime implicants are the implicants where they are going to have the minterms, which are where we are going to have at least one minterm, which is basically not shared with any other prime implicant. Okay. So let me write down over here where essential prime implicants are going to have minterms which are not shared with other implicants. Okay, which are not shared with especially essential prime implicants. Okay, and at least one minterm. We should have at least one minterm such that which are not shared with other essential prime implicants. For example, if I'm going to take the same K map and I'm going to have 1, 1, 1, 1. Okay. First of all, how many prime implicants are there over here? We have already seen that we have basically three prime implicants. Prime implicants are nothing but these are basically the possible number of groups is nothing but my prime implicants, and I have seen that there are basically three prime implicants, right? Now, this I can say it as an essential prime implicant because there is at least one minterm which is not going to share any group with other particular which is not going to share any group with others. Okay, so this minterm is not going to share group with any other particular group. So that's the reason it is essential prime implicant. So this is one essential prime implicant. Now, I can say this particular group as also essential prime implicant because there is at least one minterm which is not sharing group with any other particular groups. Okay, so that is the reason this is also one essential prime implicant. So I can say that there are basically two essential prime implicants because in this particular group, if you see this minterm is not sharing group, this particular minterm will not at all share any other group. Okay, this minterm is going to share, and in this particular group, there is at least one minterm which is not going to share group with any other particular thing. Okay, now that's the reason these two are essential prime implicants. Now let's say if there is one more group over here. In this particular third group, there are two minterms. This minterm is sharing group with other EPA and this minterm is sharing group with other EPA. So you cannot say this third group as EPI. No, you cannot say this particular third group as EPI. Is it clear for everyone? Yes or no? So essential prime implicance, is it clear? Great. Now, why are these particular essential prime implicants are important and why are we learning it? So let's say suppose if I'm going to have this problem, can anyone solve this and let me know what is the answer for this schema? Please solve the schema and let me know what is the answer, what is the final solution of this particular schema. Yes. So what is the solution of this schema? If we are going to solve it, what is it we are going to get? Let's see who can solve it. It is B complement, C complement, B complement C, BC, and BC complement, and A complement and A. We are waiting for your answers. What is the solution if you are going to solve this particular KMAP? What is the final solution you are going to get? Let's see who can answer this. AB plus A bar C. So if I take common over here, this two midterms, it is nothing but AB. Sorry, this two midterms, if I take, it is AB plus, if I take this two, then it is A bar C. AB plus A bar C. Can't we take this vertical grouping, which is present over here, which is nothing but BC? Can I take plus BC also? No, I'm not going to take it because this is not necessary. Okay. This two midterms are already grouped. Okay. And here this is not an EPA. Okay. So you can remember like this. EPA is, if it is an EPA, then only it is going to appear in your final solution. If it is not an EPA, it is not going to appear in your final solution. Okay. Or else you can remember like this. So if it is already grouped, so if you are going to have a group which is having midterms which are already involved in other another grouping, there is no need to write down that particular solution. Okay, so that's the reason this is not required. And this particular group, we are going to say it as an RPA. Okay, so which is redundant for us. We don't need that particular group. And this particular term which we are going to have is a redundant term. Okay, which is not required in our final solution. Okay, this is very, very important when we are going to solve our problems. And in HTA also, we are going to look into this particular redundant terms. Like we wantedly, we are going to add the redundant terms and all. Okay, I will discuss when we are going to discuss about HTA. Okay, so essential prime implicants, and redundant prime implicants, are they clear for everyone? Any doubts or any queries over here? Shall we move forward? Any doubts or any queries? Shall we move forward? Okay. Now, Now let's see about we have completed our prime implicants, essential prime implicants, and redundant prime implicants. Now let's see about the selective prime implicants. So before going to start with the selective prime implicants, let me give you one more function. F of E comma B comma C, I'm going to have this midterms. So I'm going to have a K-map like this. This is A, B, C. So I'm going to have one midterms like this. Now, can anyone tell me the solution after solving the schema? Quick in the chat box. B complement C, B C, B C complement, A complement, and A. After solving this, can anyone tell me? So the midterms are at positions 0, 1, 3, 4, 5, 7, 6. These are the positions. Now, I want answer after solving this particular K-map. What is the answer you are going to get after solving this particular K-map? Quick instructions. Let's see who can answer this. AB plus A. Okay, great. I got one answer. AB plus AC plus A complement B complement. I got one answer as AB plus AC plus A complement B complement. This is the one answer I got. Any other answers, or everyone is getting the same answer? I don't need redundant prime implicants to be present inside my solution. Okay, I got one different answer. AB plus BC plus A bar B bar. AB plus BC plus A complement B complement. Anyone getting any third different solution, third unique solution, or there are only two unique solutions which we are going to get? Don't include redundant prime implicants. A bar B bar plus BC plus AB. Okay. Are we getting A bar B bar? I can't see A bar B bar forming. Once check your answer. Okay. A bar B bar is also forming now. How AB is forming? How AB is forming? Okay. Let's group and let's check how AB is getting. And one third answer I got is A bar B bar plus BC plus AB. A bar B bar plus BC plus A. Okay, let's see. Okay, okay, I found it. Yeah. So here this can be grouped and this can be grouped, right? So this first group is nothing but A complement, B complement, and this group is nothing but okay, these two are same only, no? And this is nothing but AB, right? Now, so we are going to get two different solutions over here. So if some people group this, then we are going to get this particular solution, which is AB plus BC plus A bar B. Now, if people are going to group this, we are going to get this solution, which is nothing but AB plus AC plus A bar B. Now, which one is correct? Whether the first one or whether the second one? Whether the first solution is correct or whether the second solution is correct. Which particular solution is correct? Exactly. Both are correct. Here we cannot basically judge that this is correct or that is correct. So basically both particular solutions are correct because this kind of situation is known as selective prime implicant. So what do you mean by selective prime implicant? We are going to see over here. So over here, if you carefully observe for minterm number three, so this is my minterm number three, I can basically group it whether vertically or else I can basically group it horizontal. So here I have two choices, two selections I'm going to have. So that's the reason this is known as a selective prime implicant. If you are going to get a selective prime implicant, it is not said as an redundant prime implicant. You have both the choices. So if you are going to group this, then you are not going to consider this as redundant. Or if you're going to group this, then you're not going to consider this as redundant. Okay. Both are possible. Okay. So that's the reason here SPI is equal to 2 and EPIs are equal to 2 and prime implicants are basically equal to 1, 2, 3, 4. Okay. And RPS will be equal to 0. There will be no redundant prime implicant. Is it clear, guys? What do you mean by SPI? What do you mean by EPA, RPI, PI? Any doubts or any queries over here? Shall we move forward? Hello. Yeah, sure. So basically, if you see, so some people are grouping in the vertical position or some people are grouping in the horizontal direction, right? So if you carefully observe for this particular mentor, you have two options. Either you can group it horizontally or either you can group it vertically. Okay. So you have two selections for this particular mentor. So this is known as a selective prime implicant. Okay. It depends upon selection. Either you can group it with the below term or either you can group it with the beside term. Okay. So if you're going to have SPI, you cannot say, let's say suppose if you're grouping with the below term and you're going to get the term BC, then you cannot say this AC is a redundant term. No, because this is also possible. Okay. So that's the reason here you have two choices. That's the reason SPI is equal to 2 and RPI is equal to 0. Okay. Yeah. Now, let's see one problem and let's try to. Okay, you only take time and try to tell me. Let's say if I'm going to have a function with min terms 1, 5, 6, 7, 11, 12, 13, and 15. It's a four variable function. Take your time and tell me how many EPAs are there, how many PIs are there, how many SPAs are there, and how many RPAs are there. So take 5 minutes of time and tell me the solution what you're going to get. What are the PS, what are the EPS, what are the RPS, what are the SPS which are present in this particular. So okay, ma'am. Okay. Yeah. Basically, you need to find out in this particular function what are the EPAs which are present, what are the prime implicants, how many number of prime implicants, and what are those, and how many SPAs are there, and how many RPAs are there. You need to calculate and you need to tell me. This is a question which we are going to have. Okay, I will also draw it parallelly. So this is my four variable KMAP, and I'm going to have 16 number of cells. This is 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, and 10. And this is 12, 13, 15, and 14. So I'm going to have minterm over here, 6, 7, 11, and 12, 13, and 15. Yeah, anyone has got like how many prime implicants are going to dare in this particular question? What are the number of prime implicants you got? Oh, great. Essential prime implicants are 4, prime implicants are 5, RPS is equal to 1, and SP is equal to 0. Okay. Okay, others also please take your time and let me know the answers. I got two answers. EPA 4, PA 9. Okay. RPA is equal to 5. And what about SP? Okay, first let's see about PI. So this is one PI I can see. This is one. And I can see one more PI over here. This is two. And I can see one more PI forming over here, which is basically three. And I can see one more quad forming over here, which is basically four. And I can see only four prime implicants which are forming over here. This is one quad. Yeah. And this is five. So I do have five prime implicants over. So my prime implicants are basically five. These are the highest possible groups which I can form in this particular K-map. Everyone getting five prime implicants is equal to five. Yeah, please cross verify it and please check it out. So I'm going to have prime implicants is equal to five. Now, what are the essential prime implicants? Okay, I can see already the answers for essential prime implicants. That's great. Essential prime implicants is equal to four, and someone got six. Okay, what about others? What is the essential prime implicants you got? Essential prime implicants is equal to 4. Okay, okay. So coming to my essential prime implicants. So let's change the color. So this is one essential prime implicant, the quad. So let me write down over here essential prime implicants are I'm going to have 13, 15, 13, 5, 7, 15 is one essential prime implicant. 13, 5, 7, and 15, which is a quad. So one essential prime implicant. Next is this particular term. Okay. Uh, which is nothing but 1 and 5. Sigma m 1 and 5. This is one essential prime implicant. And 6 and 7. This is one more essential prime implicant. And 11 and 15. 11 and 15 is one of the essential prime implicant. And 12 and 13 is one of the essential prime implicant. Which is fine. So there is no, I don't think there is no redundant prime implicant also. So RPI Where is this redundant prime? Yeah, yeah, I can see it. Okay, first of all, EPS I got 5. EPS I got 5. Okay, fine. Now what about RPA? Can anyone tell me? Why can't we take 3, 5, 3, 5, 7? Okay, 3, 5, 5, 7. Huh? 3, where is 3, 5? 3. How can we take 3, 5? 3, 5 is cross cells now. We cannot group them. 5, 7 is not, we are not going to group because we have already formed a quad now. So if we have already have a quad, then in that quad, what is the use of grouping it? So we are not going to consider 5 and 7. Okay. And 7 and 15. 7 and 15 also we are not going to group it because it is already grouped in the quad. So after already you have formed a quad and inside that why you are going to group? There is no meaning, right? Okay. EPAs I'm going to get 4 or 5. Okay, okay. EPA I'm going to get 4 only. This is not an EPA. Quad is not an EPA. Sorry. Yeah. So EPAs are only 4. Yes. And what about RPAs? RPA is equal to 1. Your quad is an RPA. It's a redundant prime implicant. Because if you can see in your quad, you're going to have this mentor, which is already sharing group, this mentor, sharing group, this mentor, sharing group. So this mentor is also going to share the group. So all the midterms are sharing group with other groups, right? So entire quad is a RPA. Okay. So RPA is equal to 1. So in your final solution, you are not going to take this particular RPA term at all. Okay. And there is no SPA which is present. SPA is equal to 0. EPA is equal to 4 itself. Okay, so this is how we are going to calculate our SPIs, EPIs, RPIs, and SPIs. Okay, we are going to see a few more problems in our tomorrow session as today's time is up. And in tomorrow's session, we are going to deal with a few more prime implicant related problems. And if you're having any queries, please let me know. I'm open to help you. And after completing this problems related to prime implicants, we are going to discuss about few more KMAP related stuff, and we are going to wrap it up and we are going to start with combinational circuits. Okay. Yes. So that's about this particular session. And one more thing, I'm also developing this website. One second. Let me share my screen. I hope my screen is visible, right? So I'm also still this particular website is in development stage itself. So there is something which is known as roadmap, which I'm still developing it. So in this, currently Verilog has been updated, digital and all has not been updated, and you can just go to Verilog. You can click to Verilog and you can see all the particular sessions which are present over here, complete Verilog sessions, and you can just click on a particular video so that that particular session
So first
recordings
we are
will
going
be
to
available over.
okay.
Okay. And if you're a person who wants to, learn everything at your own pace, you can just go through the website and you can just have it and you can have a track of what is happening. And soon I'm also updating this particular digital designs. Digital design entire theory and problems and all that will be updated over here. And HTA, we are going to have live sessions in our upcoming month. So that will be updated over here. Okay. And yeah, so that is what. And what I need you from is, like, let's say if you have any suggestions or any queries about how a user wants to have the website, like what is your suggestions and what do you need from this particular website. And I'm also trying to add interview questions and notes regarding to all the particular topics also. Apart from that, if you have any queries, please let me know. Okay. Yeah. So yeah, so that's about this particular session. So let's meet tomorrow and let's discuss some more problems. Yes, yes, I'm adding everything. Just I'm lagging of time, so I'm not able to find time. That's the reason. I'm adding it slowly. Everything will be added slowly. Okay. So no need. So I get few messages like I want notes, I want interview questions and all. So everything will be covered in this particular website only, and that will be covered in this. Yes, I have published it. I will also share this link in this meeting. Okay. Okay then. Right. Thank you. Let's see in tomorrow's session. Okay. Yeah.